Hello everyone. Our groups include Châu, Minh Thư, Thành, Giang, Long, and Ngọc Bảo. Today, for our midterm assignment, we are going to make a Napoleon pastry. For the ingredients, we need flour, butter, cream, water, sugar, and salt to taste. So, let's get started. Firstly, we have to make the puff pastry. As the name suggests, we want a crispy and light structure, so we have to make the dough by mixing flour with cold water a little bit at a time. This is because the protein in the flour will react with warm water to make gluten, which makes the texture fluffy and chewy like bread because it traps air into the dough. So, to prevent the formation of gluten, we have to knead the dough lightly in cold water. When the dough is set and no longer sticky, we'll roll it out into a tray and spread cold butter on it. After that, we fold it in half and roll it out again. Repeat this process several times and remember to keep the butter cold, and we'll have a layered piece of dough with butter between the layers. Take an aluminum tray and spray some oil onto it to prevent sticking. Since the tray's surface isn't smooth, the oil will fill in the crevices to prevent the dough from making chemical bonds with the metal items. Now we'll cut the dough into bite-sized pieces and give them an egg wash before setting them on the tray. This will give us a nice golden brown color after baking by the Maillard reaction. While baking, the butter will melt, expanding the air trapped between the layers, and will have the desired texture. Secondly, we'll make a raisin paste. This can be made out of any kind of fruit, but since we have raisins, we'll just have to stick with that. We soak the raisin in water, which will make them swell up thanks to water seeping into them through osmosis. Grind them down into a paste by a mortar and pestle, then put them aside. Thirdly, we'll make the whipped cream, which is simply by beating heavy cream with sugar. Cream is an emulsion with a fat content of 35 to 40%. When you whip a bowl of heavy cream, the agitation and added air bubbles cause the fat globules to begin to partially coalesce into chains and clusters, which are then absorbed to and spread around the air bubbles. As the fat partially coalesce, it causes one fat stabilized air bubble to be linked to another. The whipped cream soon starts to become firm and takes on a smooth texture. This results from the formation of this partially coalesced fat structure stabilizing the air bubbles. Water, lactose, and proteins are trapped in the spaces around these bubbles as well. The crystalline fat content is essential so that the fat globules partially coalesce into a three-dimensional structure rather than large globules that are not capable of structure building. This is caused by the crystals within the globules sticking them together into chains and clusters, but still retain the individual identity of the globules. If whipped cream is whipped too far, the fat will begin to churn and butter particles will form and makes it look curdled. Because the lipid in cream is also butter, it can be easily melted in summer, so we should place that in the fridge. Below are scanning electron micrograph images of whipped cream. If you compare the schematics above with the real thing below, you should be able to fully understand whipped cream structure. The structure of whipped cream is determined by scanning electron microscopy. Picture A. Overview showing the relative size and prevalence of air bubbles A and fat globules F bar equals to 30 UM. Picture B. The internal structure of the air bubbles showing the layer of partially coalesced fat which has stabilized the bubble bar equals to 5 UM. Picture C. Details of the partially coalesced fat layer showing the interaction of the individual fat globules bar equal to 3 UM. Finally, we'll place the pastry onto a plate Then spread the raisin paste above and the whipped cream on top. The whipped cream is very light as of air inside, so it stays on top and doesn't mix with the raisin. Repeat it with 2 other layers and oh wait, come on, it fell? Oh, great! This is a perfect example of how sensitive cream is to temperature. Come on guys, let's repeat everything from the top. Finally, let's decorate it with fruit and we're done. And it melts again. Seriously! Whose idea was it to bake this thing when it's 40 degrees outside? Look, it's not that bad, okay? Well, I'm not doing it again, so we're done here. Voila and bon appetit!